All right, guys, we are going to continue talking about prisms, so stuff with two parallel congruent bases, but now we're going to talk about how we find the volume of them. Okay, so actually looking at page 118 first, we had all these prisms here. When I'm talking about finding volume, that's different than surface area. Surface area is sort of like the paper, like how much paper I have. When volume is more like how much stuff could I fit inside, like how much chocolate could fill up this cube. I don't know why I thought of chocolate. Oh, but that does sound good. Chocolate cubes. Or like how much water I could fill in a cup, okay? So the volume formula for finding volume of a prism is just the area of the base times the height. So the way that I always kind of think about it, and I can't really show it too well here because I'm just going to end up coloring in the whole shape, but I almost think of it as like this. So we have the area of the base. I have this like base flat surface, and then the height is telling me how high to stack it. So I'm like taking all these super thin little layers of like a square, and I'm just stacking them on top of each other until I fill the whole thing. So that's how I get the height in there. So that's kind of how we want to think of volume. So if we turn to page 120 and look at our volume, so I kind of have two headings here, but volume of prisms, volume of cylinders is really the same thing. The only difference is a cylinder has a cylindrical base, so a circular base, but it's not any different. The way you're going to find that volume is by doing area of the base, so area of base, and then multiplying it by the height of the prism. And remember, a height always has to be a perpendicular height. The same is true here. This is, let me get a little color going, the area of the base. It's just a very specific base because it's a circle. So area of base. And this is still the height, and it's still a perpendicular height of the prism. So from like base to base. So yeah, that's not any different. I don't remember what I was going to say about that, but that's not any different. They're the same. Okay, so if we kind of look through some of these on the front here, and then we'll try a whole bunch more on the inside. Remember, volume's about filling up all the space with like a liquid or chocolate. So if I look at this one here, whenever I have a rectangular sort of prism, those ones are always trickier. And because on the surface area one, I kind of pick the bottom, on this one I want to pick a different side because whenever it's rectangular or like square base, it kind of doesn't matter. So let's say I pick the base to actually be this side. So when we're talking about volume, we're kind of talking about this really thin layer of this piece and then stacking it along until I get to the other side. And so kind of this is the other base because it's always parallel of it. And we're stacking them up until it fills up the whole thing. So when we want to find the area of our base to get volume, we're going to do 3 times 2 for 6. And then the height has to be the height from base to base. So from side to side, that's a 6 in this case. And so we end up with 6 times 6 for a volume of 36. Now, whenever we're doing volume, that is a degree higher than area because area was like 2 sides multiplied up. This is sort of 3 sides multiplied up, so we get units cubed. So always for volume, it's units cubed. Now, just to be like maybe interesting, if I would have picked the bottom as my base, I would have done 6 times 2 for 12. And then the height from bottom to top is 3, and so I still end up with 36. So that's just to show you, like, it kind of doesn't matter the base that I pick as long as I think about it carefully and don't use maybe more numbers than once, sort of. Let's try another. So looking at this one here, I have to pick a certain base. So whenever we have a prism, the base has to be the one that there are two of. With rectangles, it's a little trickier because there's kind of lots to pick from. But with a circle, you don't have a choice. There are two circles, and those are your bases. So circle to circle. When we want to find the area of a circle, we're going to do pi r squared, which I can see in this picture here, the radius is 4. So we'll have pi times 16, or 16 pi. And then the height from base to base, they're showing me from circle to circle, is a height of 7. So when we're going to find our volume, we're going to do that area of the base, which was 16 pi, times the height, so just 7 times 16 really, because pi is just chilling. What is that, 112? 112. 112? Yeah. Units cubed. Okay, let's try a whole bunch more. So opening this one up here, let's go to that top one. That top one, I do have to be a little bit careful about the base because they are not all rectangles. They're kind of parallelograms. I feel like I'm going to go with the front. That one just seems good to me. Like if I think about the bottom, I guess I kind of know the bottom and the top. Do I know side to side? I feel like I don't know side to side. So the thing that I'm thinking about there is if I want to find the area of the space, do I have all the information for that? And so with this parallelogram at the front, I can see that I do because I have a height and a base. And then when I was thinking about it for the top and bottom, I also have that because they're showing me the height from base to base there is 4. So I do have top and bottom, but I was like thinking about side to side, and I don't know if I have that because I kind of don't know how long this is. Well, yeah, so the side to side seems hard to me. So I'm just going to go with the front because that was the most obvious. So if I'm going with the front as the base and it's parallelogram, the way I find the area of that is doing base times height, which I can see is the 8 and the 3. Then when we're talking about height of the prism, that's how far is it from the front to the back. So right here they're showing me how far it is from front to back, or base to base. So that's why this number is 4. And so when I multiply this up, we got 24 times 4 for 96 units cubed. Oh my gosh, did I forget to do that on the front with the cylinder? No, I did it. Okay, good. All right, just to shift our brains back and forth, I mean, because why not? This one here, I can definitely see that my base is a circle. And so we're going to want to do area of the base times height. In this case, because my base is a circle, the area formula for that is pi r squared. Which I feel like I can't see what the radius of that is. I don't think they gave it to me. It's like right there. And the other kind of weird thing is this 13 is sort of talking about how far it is from like the top of one side to the bottom of the other. It's sort of like this diagonal line. That then when I come up here, oh, I'm starting to see a thing. When I lift this up, we have a side connected right here at a 90. And then if I extend this radius over, which I mean I can because then it's just a diameter, I have a right triangle. And on that right triangle, I know two sides, so I can find the third. 13 is the hypotenuse, so we'll have 5 squared plus I don't know squared, which is technically the diameter of the circle, equals 13 squared. And I'm pretty sure 5 and 13 make up a triple, but let's just double check. So we got 25 d squared equals 169, and then we'd subtract that 25 for 144, yeah. So my diameter is 12, which means my radius is 6 and 6. So that's kind of a sneaky thing. But now that I have my radius, I can find the area. So because the radius is 6, we'll have 36 pi for the area of that. And then height of the prism has to be from base to base, so from circle to circle, which was that 5. And so then I want to just do the 5 times the 36 for 180 pi units cubed. Alrighty, jumping back over here. If I want to find the volume, I'm going to need to do area of the base times height. This time my base shape has to be the triangle. So triangle to triangle is what we're trying to find the volume of. So thinking about the triangle, if I want to find the area of that, I need to do half base times height. And so if I'm looking at the triangle, the base and height need to be the ones connected to the 90, and they friggin' didn't give it to me again down here. But they do tell me that this is a 10. And so we can do another Pythagorean theorem thing, but 6 and 10 are part of a triple, and their other triplet is 8. So my base and height of my triangle are 6 and 8. So I'll take half of 8 for 4. 4 times 6 for 24. Then I want to multiply by the height of the prism, so from triangle to triangle. So if I connect a triangle to a triangle, I don't see it along this edge, but all the edges will be 15. So multiply that by 15, and we're going to have a big number of units cubed, 360 units cubed. Oh, I'm just throwing a lot of stuff today. All right, looking at this next one here, if I want to find the volume of this prism, because the prism has a base of a circle, it's kind of a cylinder, and to find the area of that, you're going to do pi r squared. Luckily, they gave me the diameter, so I can know that the radius is 5. So we'll have 25 pi for the area of the base. Then for height, we want to find the height of the prism. So from circle to circle, they're showing me that that's a length of 20. I didn't necessarily mean to pick the blue and the red together, but the blue with the red with the white paper, it's just very patriotic. I love it. So when I multiply here, I'm going to have 500, right? Yeah. Gosh. 500 pi units cubed. My brain is not quite working this morning. I have not fully had my coffee. All right, let's try 2 more. Okay. If I want to find the volume of this prism, I need to find the area of the base. And this prism here kind of looks like a gold brick. We like that. Has to be the trapezoidal base, because there are 2 of those. So base does not mean bottom. Okay, so if I want to find the area of the trapezoid, we have our formula, half height times the sum of the 2 bases of the trapezoid, which are always the parallel ones. So like looking at the front trapezoid, I can definitely see that one of the parallel sides is 5, but I can't see this other one. But it's the same as the back one, so it's 2. And then we want the height of the trapezoid, so from parallel to parallel, which again, they don't show that on the front, but they do show that on the back, is 3.5. I'm going to change that to 7 over 2, because like I'm already in fraction land, because 7 over 2 is 3.5. So when I multiply this up, or like really add what's in parentheses first, we'll have 7 over 1. Just so that they're all fractions. And then the bummer is like I have 2's on the bottom, they can't go into anything on top, so really I have 49 over 4 here. I know you're not loving this. Oh, sorry. And then the height of the prism. So I'm going to fill this prism up with little slices of gold trapezoids all along trapezoid to trapezoid. So they're showing me that right here is a distance of 8 or a height of 8. And so we're going to take that our height was 8. Oh, now this is good though, because so this is 8 over 1. 4 can go into 8 twice. And so we just have 2 49s, which is 98 units cubed. You love to see it. Love it when a plan comes together. Okay, last one. So again, because I have 2 circles, when I'm finding the volume, I have to pick the circle as my base. And since the circle is my base, I'm going to find the area of that by doing pi r squared. Again, we were lucky and they gave me that the radius was 6, so 36 pi times the height, which a height has to go, again, from base to base, so like bottom to top, but it has to be perpendicular. And so it's really not that 25. They're kind of showing you that perpendicular height right here. Now the 7 is not part of your prism, but the 7 is important because the thing is, this 25 is also over here. And then what I have is a right triangle where I know 2 sides, so I can find the third. And so we'd have 7 squared plus the height squared, which I don't know but want to know, equals 25 squared. Which again, I do think this is a triple, but I don't know it off the top of my head. So I'll have 49 plus h squared equals 625. And then we will subtract that 49, or I'm not sure how much. These numbers are getting big. And like I'm probably not going to know the square root of that really big number. So 625 minus 49, and then square rooter for 24. So yeah, it is a Pythagorean triple, but I didn't know that one off the top of my head. But 7, 24, and 25 is one of those triples. So the height of the prism from circle to circle, always perpendicular, is 24. So now I'm just going to do the 24 times 36. Again, big numbers. So 864 pi units cubed if you want exact. If you do want approximate, just to practice, we'd have this. Oh my goodness. Why does it sometimes just take forever to snap in? That 864 times pi. So approximately 2,714.34 units cubed, if you want approximate. But who does? See you in the next one.